Hi guys, welcome to the second video on indices. In this session, we'll be continuing to learn a few more laws with respect to indices. So let's directly get into the laws. Yeah, so we have one more law where if I have a to the power p is equal to a to the power q, right? So when the bases are same, if a to the power p is equal to a to the power q, then I can always say that p is equal to clear, right? So for example, if I have 2 to the power 2n minus 1, which is equal to 2 to the power 9 minus 3n, since the bases are equal here, okay? Since the bases are equal, I can always say that this is 2n minus 1 is equal to 9 minus 3n, right? So if I transpose my values, I get 5n is equal to 10, or I can directly say that the value of n is equal to 2 here. So if the bases are same, I can equate the powers and I can say that the powers are equal. Right now, let's look at one more example. Suppose I have 2 to the power x plus 3 is equal to 4 to the power x minus 1. Now, I know that 4 can be written as 2 square. So, I can simplify this as 2 to the power x plus 3 is equal to 2 square whole to the power x minus 1. Or I can further rewrite this as 2 to the power x plus 3 is equal to 2 to the power 2x minus 2. Now, here the bases are equal. Right? Once the bases are equal, I can equate the powers. So I can say that x plus 3 is equal to 2x minus 2, or eventually we get the value of x is equal to 5. So that becomes our answer here. Let's look at one more question here. So here I have 5 to the power x minus 2 into 3 to the power 2x minus 3 is equal to 135. Now I see that 135 can be split as 5 into 27. Clear? So first of all, I can write this as 5 to the power x minus 2 into 3 to the power 2x minus 3 can be written as 5 to the power 1 into 3 cube. Because 27 can be written as 3 cube here. Right? Now, what I can see is this 5 to the power x minus 2, and I have on the right hand side a 5 to the power 1. So I can equate both of them. So if 5 to the power x minus 2 is equal to 5 to the power 1, I can say x minus 2 is equal to 1, or the value of x is equal to 3. Similarly, we can also equate 3 to the power 2x minus 3 is equal to 3 cube. 3 to the power 2x minus 3 is equal to 3 cube. Now I can equate the powers saying that 2x minus 3 is equal to 3. Clear? Or we have 2x is equal to 6, or we have the value of x is equal to 3. In both the cases, we get the value of x is equal to 3, and therefore that becomes our final value. Right now, we're looking at a fractional form. So first of all, we have 3 by 5 whole to the power x. So we have already seen a law that if I have a by b whole to the power n, can be written as a to the power n divided by b to the power n. So I can split this as 3 to the power x divided by 5 to the power x multiplied with 5 to the power 2x divided by 3 to the power 2x. On the right hand side, I know that 125 is a 5 cube and 27 is a 3 cube. So the numerator is a 5 cube and the denominator is a 3 cube. We can rearrange them. I can rewrite this as 5 to the power 2x minus x divided by 3 to the power 2x minus x is equal to 5 by 3 whole cube. Or we have 5 by 3 whole to the power x is equal to 5 by 3 whole cube. And since the bases are equal here, I can finally say that the value of x is equal to 3 here. Right? Let's look at one more question, guys. So one more application of this would be I have 9 to the power x plus 2. I can rearrange this as 9 to the power x plus 2 minus of 9 to the power x is equal to 720. Now 9 to the power x plus 2 can be written as 9 to the power x into 9 square, because we know that a to the power m into a to the power n will always give me a to the power m plus n. So we are applying a reverse application of this law. And I have a minus 9 to the power x is equal to 720. Or all I can do is I can take a 9 to the power x common If I take 9 to the power x common, we have 9 square minus 1 is equal to 720. Or we have 9 to the power x into 80 is equal to 720. So this 0 and this 0 gets cancelled. This is 8 ones are 8 nines are. So eventually what do we have? We have 9 to the power x is equal to 9 to the power 1. Or eventually we get the value of x is equal to 1. Clear? So we can always see how can we apply the same law in a reverse manner. Right? Let's look at one more question of this law. So 3 to the power 2x plus 1. So let's write this as 3 into 2 to the power x plus 3 minus 2 to the power x into 2 square plus 5 is equal to 0. So let's simplify this. So can I simplify this as 3 into 2 to the power x minus 4 into 2 to the power x plus 8 is equal to 0. Now we have 3 into 2 to the power x minus 4 into 2 to the power x, which will give me minus 1 into 2 to the power x plus 8 is equal to 0. Or if I transpose, I get 8 is equal to 2 to the power x. Now that 8 is nothing but 2 cubed, so I can write this as 2 cube is equal to 2 to the power x, or I can have the value of x is equal to 3. So all we try to see is in how many ways can we simplify the values given to us and bring in the form of the bases are common. If the bases are common, we can equate the powers and get our final values. Right now, let's look at one more law. This is a law of negative indices. Now, what if the power is negative? Till now, we have seen the power is positive, right? Now, if I have 8 to the power minus n, let's say divided by n. If I want to make the power positive, I have to flip the fraction, right? So, so this 1 goes on to the numerator and the denominator has 8 to the power n here. Or in short, this is nothing but, one second. So, if you're flipping it, okay, then this becomes a to the power minus of minus n. And therefore, our final outcome becomes 1 by a to the power n. So our job is to directly switch down to this point. So I repeat, if I need to make the power positive, all we have to do is we have to flip the fraction here. Similarly, if I'm given 1 by a to the power minus n, now if I want to make the n value positive, I have to flip the fraction. So I can directly say that this becomes nothing but a to the power n. Similarly here, if I'm given a fraction here, let's say a by b whole to the power minus n. If I need to make the value of n positive, I have to flip the fraction. So to make the value of n positive, I first write b by a, and then this becomes whole to the power n. So these are three different ways in which we can get these the values, and this is how we handle them. Let's look at a few examples. Now, 2 to the power minus 2 is pretty simple. I flip it. This becomes 1 by 2 square. 1 by 2 to the power minus 2 flips down to become 2 square. Now I have 1 by 3 whole to the power minus 4. If I need to make the power positive, I flip the fraction. So this becomes 3 by 1 whole to the power 4, which is as good as 3 to the power 4, which is going to be 81. This is going to be 4, and this is going to be 1 by 4. Similarly, 5 by 3 whole to the power minus 4, I need to flip the fraction. So this becomes 3 by 5 whole to the power 4. So 3 to the power 4 divided by 5 to the power 4. What is 3 to the power 4? 81. What is 5 to the power 4? 625. So therefore, 81 by 625 becomes the final value. And one last says 3 by 2 whole to the power minus 3. If I need to make the power positive, I need to flip the fraction. This becomes 2 by 3 whole cube. Into this value also becomes 2 by 3 whole square. So I have 2 by 3. The bases are the same. So I can add the numerators or the powers. So 2 by 3 whole to the power 3 plus 2, which means this becomes 2 by 3 whole to the power 5 becomes the final value of this. Now 2 to the power 5 is 32 and 3 to the power 5 is 243. So therefore the final answer becomes 32 by 243. Right, let's look at a few more examples, guys. 125 whole to the power minus 1 by 3. How do I handle this? Now, 125 is a 5 cube. Let's first simplify this. So I can write this as 5 cube within brackets minus 1 by 3. Clear? So this can be written as 5 to the power 3 into minus 1 by 3. So this 3 and 3 gets cancelled, which means we get 5 to the power minus 1. Now 5 to the power minus 1 is nothing but 1 by 1. So here we are applying a to the power m within brackets n gives us a to the power m into n. So 243 is 3 to the power 5 and 32 is 2 to the power 5 whole to the power minus 4 by 5. So this can be written as 3 by 2 whole to the power 5. Within brackets, we have minus 4 by 5, which gives us how much, guys? This is 3 by 2 whole to the power 5 into minus 4 by 5. So this 5 and 5 gets cancelled. So we get 3 by 2 whole to the power minus 4. Now, if I need to make the power positive, I need to flip the fraction. So this can be written as 2 by 3 whole to the power 4, which is 2 to the power 4, which is 16, and 3 to the power 4 will give me 81. Now, 64 is an 8 square and 25 is a 5 square. So I can write this as 8 by 5 whole to the power minus whole square into minus 3 by 2. So 2 and 2 gets cancelled. Now the value here becomes 8 by 5 whole to the power minus 3. If I need to make the power positive, I need to flip my fractions. This can be written as 5 by 8 whole cube. Now 5 cube is 125, whereas 8 cube, okay, 8 cube can be written as 2 to the power 9. 2 to the power 9 is going to be 512. So this becomes our final value, right? Now let's look at a few more applications here. So we have 2 by 3 whole square. So we can write a by b whole to the power m can be written as a to the power m divided by b to the power m. So I can write this as 2 square by 3 square multiplied with. We have 2 by 5 whole to the power minus 3. To make the power positive, I need to flip the fraction. So this can be written as 5 cube by 2 cube multiplied with 3 by 2 whole cube can give me 3 cube by 2. So if I need to simplify this, I can write the numerator as a 5 cube into, this is 3 cube in the numerator and 3 square in the denominator. So we can apply a to the power m divided by a to the power n is equal to a to the power m minus n. So I can write this as 3 to the power 3 minus 2. Similarly, I have 2 to the power 3 plus 3 in the denominator and I have a 2 square in the numerator. So I can bring that down and I can subtract that here. So this final value becomes 5 cube into 3 divided by 2 to the power 6 minus 2. That gives me 2 to the power 4. Clear? Which eventually gives us 5 cube is 125. 125 into 3 divided by 16. And the final value becomes 375 divided by 16. Right, guys, let's look at one more example here. So 81 by 16 whole to the power minus 3 by 4. Now 81 is 3 to the power 4. 16 is 2 to the power 4 whole to the power minus 3 by 4 multiplied with 25 is 5 square, 9 is 3 square whole to the power minus 3 by 2. I have a division, so I can convert that into multiplication. So 2 by 5 whole to the power minus 3. This is a simplified form of the fraction or the question given to us. Now, we can write this as 3 by 2 whole to the power 4 into minus 3 by 4. This 4 and 4 gets cancelled. Multiplied with. This can be written as 5 by 3 whole to the power 2 into minus 3 by 2. This 2 and 2 gets cancelled. Multiplied with. This can be written as 2 by 5 whole to the power minus 3. Now, let's make all the powers positive here. So to make the powers positive, I need to flip the fraction. So this becomes 2 cube by 3 cube. Multiplied with this becomes 3 cube by 5 cube. Multiplied with this becomes 5 cube by 2 cube. So this 2 cube and this 2 cube gets cancelled. Similarly, this 3 cube and this 3 cube gets cancelled, and this 5 cube and 5 cube gets cancelled, and therefore the final answer is going to be 1. So complex question like this gives us the answer called 1 here. Right, guys, let's look at one more question here. So 5 to the power 2x divided by 5 to the power minus 3. Right, so first of all, this can be written as 5 to the power 2x divided by 5 to the power minus 3 is equal to 5 to the power 5. Now, if the power is negative, to make the power positive, I need to flip the fraction. So this can be written as 5 to the power 2x into 5 cube is equal to 5 to the power 5. Or eventually we have 5 to the power 2x plus 3 is equal to 5 to the power 5. So since the bases are same, we can equate the numerators. So we have 2x plus 3 is equal to 5, or we have 2x is equal to 2, or we get the value of x is equal to 1. So what we can apply here? We are applying if a to the power p is equal to a to the power q, then we can say p is equal to q. Clear? Now, we have fractional index. So if I have nth root of a, to simplify this, the value of this becomes a to the power 1 by n. So this time, we are looking at the value of the fractional index, where the power is a fraction, right? Similarly, if I have nth root of ab, can we split as nth root of a into nth root of b, which can further be written as 1 a to the power 1 by n into b to the power 1 by n. Whatever is the value of n, that becomes the fractional numerator here. Right? So, for example, this is a square root of 13. Square root of 13 can be written as 13 to the power 1 by 2. Third power of 17 can be written as 17 to the power 1 by 3. And fourth root of 19 can be written as 19 to the power 1 by 4. Similarly, square root of 15. Now 15 can be written as square root of 3 into 5. So I can write this as square root of 3 into square root of 5, which is 3 to the power 1 by 2 into 5 to the power 1 by 2. Now cube root of 21 can be written as cube root of 3 into 7. So this can be written as cube root of 3 into cube root of 7, which can be written as 3 to the power 1 by 3 into 7 to the power 1 by 3. Similarly, fourth root of 35 can be written as fourth root of 5 into 7, which will be fourth root of 5 into fourth root of 7, which will eventually give me 5 to the power 1 by 4 into 7 to the power 1 by 4. So this is how we deal with fractional index, right? Now the final application here is if I have the combination of all of these, I have a to the power y and I have x root of it. So this can be written as a to the power y into 1 by x, which will eventually give me a to the power y by x. So 8 square and 2 cube, this can be written as 8 to the power 2 by 3. Now further 8 can be written as 2 cube to the power 2 by 3. 3 and 3 gets cancelled. So you have a 2 square and a 2 square becomes 4. So the fourth root of 81. 81 is 3 to the power 4 and I have a fourth root of it. So this can be written as 3 to the power 4 by 4. 4 by 4 gives me 1. The value is 3 to the power 1, which is going to be 3. Clear? Now let's look at application of these. So 32 to the power minus 3 and it's a fifth root. So let me simplify this first. This can be written as 32 to the power minus 3 divided by 5. Whatever is the root, that becomes a fraction and the minus 3 remains as it is. Now 32 is 2 to the power 5 into minus 3 by 5. So 5 and 5 gets cancelled. Eventually we have 2 to the power minus 3 and 2 to the power minus 3 is nothing but 1 by h. Similarly here, this is 1 by 4 to the power minus 5 by 3. To make the power positive, I need to flip the fraction. So this can be written as 4 to the power 5 by 3. Clear? Now here, this is a very interesting question. So first of all, let's look at this part. I am looking at cube root of x square first. If I write cube root of x square, this can be written as x to the power 2 by 3. over and above this, I have a fourth root. So I repeat, over and above this, I have a fourth root, which means this becomes x to the power 2 by 3 into 1 by 4. So eventually this 2 and this 2 gets cancelled. So we have x to the power 1 by 6 is the simplified form of this question. Clear, guys? So I repeat, whatever is the root given to us, that becomes a fractional index. And that's how we are applying this, right? Let's look at this question. This can be written as 2 to the power 5x into or divided by 2 to the power x is equal to 2 to the power 20. This is the fifth root, so this becomes a fractional index. So 5 ones are 5 fours are. So this can be written as 2 to the power 5x minus x is equal to 2 to the power 4. Or we have 2 to the power 4x is equal to 2 to the power 4. Now the bases are same. If the bases are same, we have 4x is equal to 4 or the value of x is equal to 1 here. Right. So let's look at the last question of this session, guys. So I have x to the power minus 1. This can be written as square root of y by x into square root of z by y into square root of x by z. Clear? Right. So what do we have here? The square root can be written as square root of y divided by square root of x into square root of z divided by square root of y into square root of x divided by square root of z. So you can see square root of x gets cancelled, square root of z gets cancelled, and square root of y gets cancelled. And therefore, the final value is going to be 1 here. So this is the summary of all the postulates that we have learned so far, guys, right? So all I would advise is you to remember these postulates. These are the foundation laws of indices. The advanced models will be taught in the class. So come prepared to the class so that the learning in the class becomes much better. Thank you, guys. All the best.